Stone Labby and friends. Our homework today is 17.3 and 17.4. You may not be watching this until Monday, but if you're on your A game and it's the weekend, good job. So we were just talking about what relative and frequency means. So frequency we've determined is the amount of time something happens, or how often something occurs. But why is this relative frequency? What is it relative to? So something is relative to how often it happens. How often it happens is related to how often it happens. That doesn't really make sense. How often it happens needs to be related to something else. See?
The thing you're doing probability. Total number of trials. The number of times.
How often something happens is related or relative to the total number of trials. So relative frequency is based off your experiment, your data. Relative frequency is the same thing as experimental probability. Relative frequency is the same thing as experimental probability, so you might want to put a little equals and remind yourself it's the same as experimental probability. So, we want to spin this spinner 40 times. Now wait, what? 40 times? Let's go back to digits. This will get easier. So, we are going to run the trials on this. Now, sometimes this works and sometimes it doesn't. Here we go. So, first I'm just going to do 10 trials because I want to show you guys how this works. In digits, in your math tools, is a probability tools page. In there, I can tell it how many trials I want to run, and then it will just generate my outcomes. So I tell it to run, I got a 3. It spins again, I get a 4. It spins again, and I get a 1. Now, while this is spinning and collecting all these, are all the numbers up there equally likely to occur? Why? Raise your hand and tell me why this might not, Nate, be equally chanced.
There aren't the same amount
There aren't the same amount
of numbers.
of each numbers. Are number 1 and number 2 equally likely to occur?
Yes.
Yeah, because both of them have 2 possible outcomes. Like 2 slices, we could say. What about number 3? Is it more or less likely? Less likely, because it only gets 1 slice. And the 4 is more likely because it gets 3 slices. So once I do my, once I find my results, it will tell me, here were your 10 trials. Here were the outcomes. You got a 3, you got a 4, you got a 1, you got a 1, you got a 2, you got a 4, a 4, a 2, a 3, a 4. So when I look at the relative frequency, we're just going to do out of 10. I know it says out of 40, but we're going to make this easy and go quicker. What's the relative frequency that I would spin a 2? So based off my data that I've collected, I know this is going to be over 10 because it's over my total trials. How many times did I get 2 as an outcome?
2 times.
2 times, right? It's right here, and it's right here. So my relative frequency is 2 out of 10. It's that easy. My relative frequency of spinning an odd number? Well, I see a 3, a 1. Red is apparently not working today. Okay. Green's going to work, though. Or maybe red is going to work, but delayed. So what's my relative frequency of getting an odd? 4 out of 10, right? It's just however many you got, whatever situation you're looking for, over the total. Do we think we understand relative frequency?
Yes.
So, we had 4 different outcomes now. Let's say we're on that same spinner. This is my outcome table from spinning 40 times. So this is what the outcome was, and then below it is how many times it occurred. Frequency remembers how many times it occurred. So if I talk about the relative frequency, so I'm going to abbreviate this RF, of getting a 1. What's my relative frequency of getting a 1? How many times does it happen versus how many total trials we took? My total trials that we took are 40. So it's going to be 10 over 40, or it reduces to 1 over 4 or that would be a 25% chance. Because I had 10 outcomes of 1, and I did 40 total trials. So now my relative frequency of getting a 2, how many times does 2 occur? 12 out of a total 40. Both of these can be divided by 4, actually. So this becomes 3 over 10, and that would be 0.3 or 30%. What's my relative frequency, if I can get ready to work, of getting a 3? What is it? 4 out of 40, or 1 out of 10, or 10% chance. And my frequency of getting a 4, of course, would be 14 out of 40. We could reduce that down. We could find that percentage. We could solve that. Yeah, it could come down to 7 out of 20, which then we could multiply up to get it to 100. Yeah, it'd be 35 over 100, or 35%. So we could keep doing these, but I think you guys get it. So the probability that an event occurs, instead of writing RF, like relative frequency of something occurs, instead we just use P. We say the probability of whatever's inside your parentheses is the outcome you're looking for. It's the event you want to happen. So probability of my event, so say rolling a 2, or spinning a 2, or getting an odd number, or picking a red marble. So whatever we're looking for, this is the same as relative frequency, number of times it occurs over total number of trials. So here, write the probability as a fraction and a percent. So it's easiest if we go fraction, then decimal, then percent. So, what's the question? Find the experimental probability that the customer asks for a plastic bag. So take about 30 seconds. Find that on your own. What's the experimental probability that a customer will ask for plastic bags? Mm-hmm. I want fraction and decimal and percent. So we would say P of plastic. Ella, how many times did plastic occur? What is the frequency of it? 18, right? That's how many people chose it. Seth, what should go in my denominator?
32.
How'd you figure that out?
I took 6, 8, and 18 and added them together.
If I add these together, I get 32. So 18 over 32 is my fraction. I could reduce that to like 9/16, but that's not very nice. So I could do the division and get a decimal value of... James, you got me?
Yeah, 1 second.
9/16. I know what it's going to be close to.
About 0.6.
So give me what it is exactly.
0.565.
So then to look at this as a percent, and this is why, James, I asked for it exactly, we'll move my decimal 2 places. If we had just put approximately 0.6, my percent would be pretty far off. But this is about a 56% chance that the person checking out is going to ask for a plastic bag. And I'm sure that percentage has gotten lower as people care more and more about the environment and they use their own reusable bags. Can you guys do this on your own? Are we good to move on?
Yeah.
I figured.
I guess it's not challenging for me.
It is understandable. If you're searching for a synonym for easy.
Okay, as the captain of the visiting team, you get to flip the coin to decide who starts with the ball. First, you must choose heads or tails, and then you may flip the coin. If you call heads and the coin lands on heads, then you get to choose who starts. If you call heads and the coin lands on tails, the home captain gets to choose. I will warn you that there is a 50% chance that the coin will in fact land on heads. Any questions?
No, ref. We pretty much get the picture.
So, when you go out in the middle of the field for your coin toss, does the ref explain like that? No, because most people understand that if there are 2 teams and you are flipping a coin, what's your chance of getting what you want?
1/2.
1/2. There are 2 outcomes. So my theoretical probability is not based off anything that I've done. It's only based off the information that I know. Theoretical probability has nothing to do with trials. When we ask for theoretical probability, it's just based off the math. So, on your notes, what I want you to write off here off to the side is based off only math. Or based on. I guess on is a better word. Only math. No experiment is involved. No trials, no tests, just the math. Which makes this easy. Because we don't have to do anything. It's just like making predictions. So, here we have a number cube, which instead of using a die with the dots, maybe we're trying to make it easy for little kids. So we have a number cube. Each side is numbered 0, 1, 2, 3, 4, 5. Or sorry, not 5, 0. So, what is the probability of rolling a 1? This is not what they're asking. I'm just having a conversation with you. So, there are 1 ones.
Oh, is that what you rolled? Is that step 2 the sample space?
This is your sample space.
I thought those were the faces of the die.
These are the faces of the die.
Oh.
So, you have 0, 2, 3, and then they turn the die the other way so you can see 0, 1, 4. So this is not a fair number cube. It is a number cube, but it's not fair. Because the probability of getting a 1, there's one outcome of 1 over how many total sides? 6. Probability of getting a 2 or a 3 or a 4, all the exact same. But when we look at the probability of getting a 0, maybe this is a die used in a game, and you get to move 0 spaces now. Like, it's more likely that you move 0 spaces. So how many times could it happen? 2 times. Out of how many outcomes are there total? 6. We reduce it, and that would be about 33 1/3%. Questions? Theoretical probability, we don't do anything. We base it all off the math that we see. Now, does that actually mean that every 3 times I roll the die, I will get 1 0? No. Theoretical and experimental will not always match. They almost never match. We've done a lab about that. I think you guys get that. Shaheeb?
I was going to say that if you do it enough times, then it
What law is that? Tag team Zach if you need. Yeah, the law of big or large numbers. Gentlemen, we okay? Are we all trying to weigh in on Rye's hairstyle or what?
Oh, sorry. I'm trying
fine.
to focus.
It's okay. It's like a coping mechanism. Right? It doesn't matter.
Sorry.
If it distracts you, you can move. So the law of large numbers states that when we're comparing experimental to theoretical probability, the more trials I do in my experimental probability, the closer I will get to the theoretical probability.
What if you just keep getting one number?
That wouldn't happen. Because your probability of getting the same number over and over and over again. So let's say this number cube, right? My probability of getting a 0 is 1/3 on 1 roll. But the next roll I take, the probability of getting a 0 is 1/3. The next roll I take, the probability of getting a 0 is 1/3. So this is the next chapter. It's compound probabilities. But the probability of getting 3 zeros in a row is 1 out of 27. Because every event, every time you do the trial, you are multiplying with your previous probabilities. So to get a next 0, I now will have a probability that's 1 over 81. If I do it again, the probability of getting another 0, it keeps getting rarer and rarer and rarer. This is also how casinos operate. They understand the probability. They're more likely to win than you are. You walk into you walk into a casino already at a disadvantage. There's no game in the casino that you have an advantage at, because they wouldn't have that wouldn't make any sense. If you have the advantage, they're going to lose money. The point of a casino is they make money. Now, occasionally people win, but that's because even though a probability is rare, doesn't mean it won't happen. Yeah?
Like the lottery, that like the huge.
Yeah. Powerball, right?
Yeah.
Powerball only gets up to big values because nobody wins. Nobody wins, nobody wins, nobody wins, nobody wins. And finally somebody wins just because eventually the outcome will happen. But the bigger the jackpot, that also means the more people that will probably buy tickets and the lower your individual probability is of winning. The more tickets there are, the more possible outcomes, the rarer your outcome will be.
Do they have Powerball in like Kansas?
I think Powerball is nationwide. Some lotteries only Ohio and some's a nationwide thing. I think Powerball is nationwide.
Yeah, I think the big one is.
Because
Yeah.
wouldn't you have a better chance of winning the lottery if you were in Kansas because like there's less people?
But that would be if it's only a Kansas lottery. But if that lottery happening in Kansas happens everywhere, that doesn't change your probability at all.
Like Montana.
Yeah.
You have a bigger chance.
So equally likely outcomes, most probabilities that we talk about, coin rolling, card choosing, that sort of thing, every outcome is equally likely to occur. What's the probability of getting a king of hearts? 152, or 1 out of 52. What's the probability of getting an ace of spades? 1 out of 52. 3 of diamonds, ace of spades, 1 out of 52. So equally likely outcomes. Spinners, we can have any amount of outcomes on spinners. You can just design it that way. 6 equally likely outcomes, we'll use a die. 2 equally likely outcomes, we just toss a coin. So let's talk about these probabilities really fast, and I'll probably let you guys just get rolling on some homework. So we'll still have like over 20 minutes. So what's the probability of getting a red here? Let's go, we will go cards. Noah?
Red button.
What?
What are the red buttons?
Well, red slices, or whatever you want to call it, I guess.
Oh, this one, yeah. Oh, I can't tell.
No, we're not doing buttons.
Look up here, bro.
Oh, we're doing the spinner. I thought
Yeah.
I thought you were looking at the buttons.
No, I'm kind of skipping through things.
Okay.
Well, and this
There's a
sucks on your printout, so yeah, we're probably not going to do that one.
3 out of 8.
3 out of 8, right? So, if you were really good with your fractions, 1/8 is 0.125. So 3/8 will be 37.5%. What about red with an odd number? Nate? 1/8.
Okay.
So when I evaluate that, it will, when I process through, become 12.5%. Probability of getting a green,
Oh, 4.
2/8, or you could just reduce it in your head to 1/4, which we all know is 25%. Now, probability of getting a number less than 10.
100%.
8/8. So 100%. You will always get a number less than 10. Probability of getting a yellow.
0 out of 8.
There are no outcomes that satisfy that, so it's 0/8 or 0%. What about blue with an odd number?
2 8.
Same thing
5%.
as your green. Does this all make sense?
Yeah.
I will post the homework right now for the rest of the chapter, and you guys can work as efficiently as you want.